Hello, welcome to this video. So this problem will be another problem about sequence and series in section B of paper 1, the conventional parts. Again, so we are given two sequences. Part A, will be about AN. And then we are not given what type of sequence it is. So that's why here, we may need to use the general term, the nth term of AN, to find out what type of sequence AN it is. Okay, so for part A, we may need to check A2 minus A1 equals so by putting n equals 2 into the general term of AN to find out the value of the second term. Similarly for A1, the first term of AN. Okay, so that would be 3 minus -1, so that would be 4. Similarly, we try to find out the difference between A3 and A2. Okay, so simply the difference between the third and the second term of the sequence AN. So and then that would be 7 minus 3. And that would be 4 again. As expected, maybe. So because, A2 minus A1 equals A3 minus A2 equals to 4. So A1, A2, A3, ... is an AS with common difference 4. Okay. And then, from the question, so for part A, we need to find A1 plus A2 plus A3 plus blah 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 up to AN. So that's why here, so of course, we need to find, we need to use the SN formula to express the sum. Okay, so that's why here, so A1 plus A2 plus A3 plus blah blah blah. Okay, so the number of terms will be n. Okay, so n over 2 times 2a, where a will be -1. Okay, as found above, and then plus m minus 1 times 4. And then after the simplification, so maybe you can simplify a bit first. So that would be 4n minus 4 minus 2, so that would be 4n minus 6. And then 4 and 6 are divisible by 2, so that would be 2 and 3, and then multiply the n inside the bracket. So and then we will get a quadratic expression. So that would be 2n squared minus 3n. And then that's for part A. Okay, part B. Let's look at part B. Find the greatest value of n, such that it satisfies the following inequality involving logarithm, log b1, b2, b3 up to bn, and then time up to bn, less than or equal to 8,000. So here, so maybe for part B, put it here. So here, you try to look at, so what's the relationship between an and bn? So here you can see, for all positive integer n, so you can see bn equals to 10 to the power of an. And then using the relationship between exponential function and the logarithm function. So this equation, okay, will be expressed in exponential form. So that's why you can see if you try to make an as the subject, so that's why log of bn equals to an for any positive integer n. Okay, so that's why here, okay, so the given inequality, okay, so log of b1 times b2 times b3 blah 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 times bn less than or equal to 8,000. Using the logarithm property, okay, so this is a logarithm of a product. Okay, we can split it into n logarithms. Okay, the sum of n logarithms. So that would be log b1 plus log b2 plus log b3 plus blah 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 up to log of bn. And then from the above, okay, so since logarithm of bn equals to an for all n, so that's why log b1 equals to a1, this is a2, this is a3. Okay, so and then we try to use the result from part A because, okay, we have a1 plus a2 plus blah 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 up to an, so that will be 2n squared minus 3n less than or equal to 8,000. So and then by rewriting the quadratic inequality back to its quadratic form and then try to use the formula O1, so that will be 2n plus 125 and then n minus 64. Okay, then okay, we may try to sketch, okay, the corresponding parabola. Okay, so that will be in the form of y equals 2n squared minus 3n minus 8,000. Okay, so and then the 2n intercepts, okay, as found by the calculator, so that would be negative 62.5, and then that is 64. Okay, so since, okay, the question, okay, or the inequality wants to find the values of m such that the corresponding y values, okay, the corresponding output values, okay, are less than 0. Okay, so that's why we want this part. So that's why, okay, the overall solutions, okay, would be well, actually, okay, would be 2 and the inequality, so that would be between negative 62.5 and 64. Okay, so and then what will be the final value, okay, of m we want there? Okay, so the greatest value of n, okay, will be simply 64. Okay, so and then the problem is done. Thank you for watching.